Okay, we will evaluate this line integral composed of the vector field F and the position vector R, and the way we will do this is we will use the fact that F dr is the same exact thing as F of R of t dotted with R prime of t. We will find R prime of t, and we'll find the composite function of F of R of t, take the dot product between these two, and integrate from 0 to 1. So R prime of t is the derivative, so that would be 9 times 14 t to the 8 plus 6 t to the 5, and F of R of t will just be so we replace the x with 14t to the 9 and y with t to the 6, because x and y, this is supposed to be to the 4, which makes the derivative different, of course. X represents the x component of the r vector, and y represents the y component. So this is 4 times 14 t to the 3rd. Okay, f of r of t will be 14 t to the 4th. So it's x times y, so 14 t to the 4th times t to the 6. That's times y, t to the 6, and that's the I component, plus 9y squared. So we will replace the y with its value of t to the 6. And now this will become, the line integral becomes the integral of the dot product between this vector here and this vector here, and the dot product is nothing but the, forgot the component here, is nothing but the multiplication. It's a scalar quantity, and it represents the multiplication of the x with the x plus the y with the y. So 14 t to the 4 t to the 6 times 4 times 14 t cubed plus, note I dot I is equal to 1. Same thing for j dot j and k dot k. So plus 6 t to the 5 times t to the 6 squared. And there's, of course, a gt on each one of those r prime components that I didn't write there, but I will include here. And we are integrating from 0 to 1. This is a fairly straightforward integral. I will not do the details, but if you guys bear with me for a minute, I will give the answer.